In this lecture, we are going to describe the concept of force vector and the type of operations that we often need to perform on such vectors when dealing with structures. Consider these structural systems. They need to carry certain loads, but how do we know if they are strong enough to actually carry the load safely? In order to ensure the safety and reliability of such systems, we need to be able to determine stresses that develop in the structural members under the applied loads. We often define stress in terms of force. Therefore, the concept of force is central to the study of the mechanics of structures. Force is a vector. It has a magnitude and a direction. Consider the weight of a typical traffic light. For structural analysis purposes, we can represent it as a vector, like this. A vector has a tail, a head, and a magnitude. The length of the vector represents its magnitude. Alternatively, we can write the vector's magnitude next to it, like this. A vector also has a direction. Here the force is pointing downward, or more accurately, it makes a 90-degree angle in the clockwise direction with the horizontal axis. We can also define a line of action for our vector. This is the line that passes through the head and tail of the vector and extends infinitely in either direction. When dealing with mechanics problems, we may also be interested in the point of application of the force. What kind of operations do we need to be able to perform on force vectors? Consider this construction crane. Each of the cables attached to the tip of the mast carries a force, like this. Collectively, these forces are pressing down on the mast. Therefore, the force that the mast must be able to carry is the sum of the cable forces. Finding this sum requires vector addition, an operation on vectors that we are going to examine in this lecture. Here is a force vector having a magnitude of 25 kilonewtons. The vector makes a 36.87 degree angle with x-axis. Since the vector lies in an xy plane, it can be represented using a vector along x-axis and a vector along y-axis, like this. We often want to represent vectors in terms of their x and y components because it makes vector addition simpler. But how do we go from here to here? How do we determine the magnitude of these two component vectors? A vector and its x and y components always form a right triangle, like this. The length of each side of the triangle represents the magnitude of a vector. This length represents the magnitude of our 25 kilonewton force. This length represents the magnitude of the x component of the force, 20 kilonewtons. And this length represents the magnitude of the y component of the force, which is 15 kilonewtons. Note how the Pythagorean theorem holds true here. Alternatively, instead of shifting the y component of the force, we can shift its x component in order to form a right triangle, like this. It gives us the exact same relationship between the sides of the triangle as before. Given that this is always a right triangle, and we know its interior angles, then we can use trigonometry to figure out the side lengths. That is, knowing the magnitude and orientation of a force vector, we can easily determine its x and y components. Let's refer to this unknown length as fx and call this length fy. Then we can write sine of 36.87 equals fy over 25, and cosine of 36.87 equals fx over 25. This gives us 15 kilonewtons for fy and 20 kilonewtons for fx. So we can replace this vector with these component vectors and vice versa. Now consider this force vector. Here is the line of action of the vector. It is important to note that no matter where the vector is located on its line of action, we get the same x and y components for the force. To calculate the vector components, we place the origin of our coordinate system at the tail of the vector. Let's assume the vector makes a 45-degree angle with a horizontal axis. We construct our right triangle by making our vector its hypotenuse. We label the horizontal side of the triangle fx, and we call the vertical side fy. Now we use the definition of sine and cosine to determine these unknown lengths. These are the x and y components of the given force vector. What if the vector has a negative magnitude? How do we determine its components? Suppose our vector has a magnitude of negative 10 kilonewtons, and it makes a 30-degree angle with y-axis. A negative magnitude simply means the vector is actually acting in the opposite direction to what is shown. One way to deal with such a vector is to correct its direction, to rotate it 180 degrees, and change its magnitude from negative to positive, like this. Now we can determine its x and y components as before. Let's place the tail of the vector at the origin. Here is our right triangle in which the 10 kilonewton force acts as the hypotenuse. Label the length of the horizontal side fx and refer to the vertical side as fy. Then solve for the side lengths using the definition of sine and cosine, like this. Here are the vector components. Now suppose we are given the x and y components of a vector and we are asked to determine its magnitude and direction. Here, all we have to do is to add the two component vectors in order to determine the magnitude of the parent vector. We start by forming a right triangle by moving one of the vectors without changing its orientation such that its tail is placed at the head of the other vector. This can be done in one of two ways, either like this or like this. We then draw a tail-to-head vector, like this. We call this the resultant vector. We are after its magnitude and direction. Note that the vector defines the hypotenuse of the triangle. Therefore, we can calculate its length using the Pythagorean theorem. What remains to be determined is the orientation of the resultant vector, which we can define using the angle that the vector makes with the horizontal or vertical axis. The angle can be calculated using the definition of tangent, like this. So this pair of component vectors is equivalent to this resultant vector. Knowing how to express a vector in terms of its x and y components, we are now ready to see how two or more vectors can be added together. Consider the following two vectors. To add them together, let's consider each vector in isolation and determine its x and y components, like this. We can replace the original vectors with these two pairs of vectors. We then add these x components together. This gives us a force vector along x-axis with a magnitude of 7.3 kilonewtons. And we add the y components together to get a vector with a magnitude of 7.7 kilonewtons. This represents the sum of these vectors in component form. We then add the two components together to get a single resultant vector. The magnitude of this vector can be determined using the Pythagorean theorem, like this. And the orientation of the vector can be determined using trigonometry, like this. Here is our resultant vector. In summary, vector addition involves representing each vector in terms of its x and y components. Then add all the x components together and add all the y components together in order to determine the x and y components of the resultant vector. See if you can correctly solve the following vector addition and subtraction problems.